Good morning, this is the Bilbao Navigation School and today's lesson is with the ship's catenary. So we have written all the formulae related with, and we are going to try to find out how we have get all these formulae and how also to apply to our problem. Our problem is to know how much zinc we have in the air and where is touching the bottom. So if we got a vessel here, like this, and here is the house pipe, we got this, the chain, this will be the C button, and this will be the depth, this will be D for depth, X, touchdown point, and S means change in the air. So first we are going to try to find out how we get this first formula. Well, in the house pipe we have the tension on the chain, the horizontal tension, and the weight of the chain. That will be W by S. That is, W is weight per meter, and S is the number of meters. So we are going to try to find out the first formula from there, over there, sorry. So on this triangle we have that W by S multiplied by W by S divided by H will be the first derivative. So W by S will be H by the first derivative, so differentiating both sides, we will get this. Well, so we will get that. Now we are going to find out the value of this. This will be a small portion of here, and we remember from Pythagoras how to solve this. ds to the square equals dy to the square plus dx to the square divided both by ds to the square equals dy to the square divided by dx to the square plus 1. So ds divided by dx is equal to the square root of all of this. Now, to make something that is more classical, so ds equals the square root of 1 plus the first derivative to the square multiplied by dx. So we take this value over here and we get that w by the first derivative of, the value of s, that is 1 by the first derivative of to the square by dx equals h by the second derivative. So w divided by h by dx is equal to the second derivative divided by 1 by, plus 1. It's exactly the same for doing a little bit more classic view of this, or not exactly, not, is the other, I think. No, I think it's more classical to write this like that. Never mind, it's still the same. And so, but for those who remember the integration, well, now we have to integrate this, both sides. And I'm going to erase this. And we get divided by the first derivative to the square equals w divided by h by dx. Integrating both sides, if we resort to the table, we will get this that is the inverse of the hyperbolic sign of the first derivative, and the integral of this will be wx divided by h. So going to the other side, the first derivative will be equal to the hyperbolic sign of wx divided by h. So the function will be h divided by w by the hyperbolic cosine of wx divided by h. Well, so here we have this one. Now we are going to find out this one, and we will explain why, and later on this one. Well, I'm going to erase this too. When the catenary, if this is the origin, the catenary is doing something like that. So, if I go to this formula, or to this formula over there, so I will see that if x is 1, this will be 1, 2, so the value of y will be h divided by w. That means, on this case, h divided by w, while this will be the depth. So, if I want to find out the depth, the only thing that I have to do, the only thing I got to do is to y subtract this amount, h divided by w. That is what I have done here. Exactly that. Well, so, and now I'm going to go to s. Well, we have said that the first derivative is this, and also we have said that I have erased, but probably I can remember that ws divided by h was the first derivative, so s is equal to h divided by w by the first derivative. And as the value of the first derivative is this one, so s equals h divided by w by the hyperbolic sign of wx divided by h. So I have the third. Now we are going to see this one, x. I have another formula for x, that is that one, and I'm going to try to find out from where it's coming at. I'm going to erase all this then. When I have said that the integral is the hyperbolic sign to the inverse of the hyperbolic sign of the first derivative, is also the integral is also the natural logarithm of the first derivative plus the square of 1 plus the second derivative to the square. And remember that the first derivative was equal to the hyperbolic sign of w divided by h. So taking that value over here, I will get natural logarithm of hyperbolic sign to the square of wx divided by h plus the square root, where is the hyperbolic sign of wx divided by h to the square plus 1. Well, and now, and all this was equal, you remember, was equal to wx divided by h. All this was equal to wx divided by h. Well, and now we are going to do some substitutions here and see if we can find out the value of x. Well,